This is Mr. Precella. Welcome back after the break. We're continuing our discussion of trigonometric identities. And let's see, we are now up to this problem. It says, write the expression in terms of sine or cosine and then simplify so that no quotient appears in your answer. So you don't want a fraction. Well, to write in terms of sine or cosine, this secant we could write as 1 over cosine. So we have 1 over cosine theta. No, that's an alpha. Then minus, rewrite, or don't rewrite, just recopy cosine alpha. And notice how I have that written. I'm going to go ahead and write this as a fraction, because now we're just going to subtract two fractions. In order to subtract fractions, you must have a common denominator. So the common denominator here would be cosine alpha. And this first fraction already has a cosine alpha in its denominator, so I'll just write 1. Then I'll carry over this minus. Notice how I'm writing it all as one big fraction. Now what about that pink one? Cosine alpha over 1. In order to write that as cosine alpha minus 1, in order to write this with a cosine alpha down there, that would mean I'd need to multiply down here by cosine alpha, which means I also need to multiply the top by cosine alpha. So we would have cosine squared alpha. And hopefully you're getting accustomed to recognizing these Pythagorean identities. When I see a 1 minus cosine squared alpha, I think of this first Pythagorean identity right here. So what I'm about to write is just my thoughts. I'll do it in the invisible orange ink. So these are just my thoughts. Sine squared alpha plus cosine squared alpha is 1. Therefore, 1 minus cosine squared alpha, you need to move the cosine squared alpha over. So 1 minus cosine squared alpha is sine squared alpha. So this top here can be replaced with sine squared alpha. So we have sine squared alpha over cosine alpha, which still isn't a correct answer because we're told we don't want any quotient, so there shouldn't be any fractions in our answer. So what can we do? Well, we can sort of think of this sine square as sine alpha times sine alpha all over cosine alpha. Well, take one of these sine alphas and think of it like this. The sine alpha over cosine alpha, the stuff I've just circled, that's tangent alpha. And then we still have this sine alpha right here, which I'm just going to recopy. Which puts sine alpha times tangent alpha as the answer choice there. Now, let's see. Here's another. This one's a little different. It says, establish the identity sine theta times secant theta equals tangent theta. And then what the answer choices look like, it's showing the steps. Well, I don't want you just to read it and try to figure out like that. You've got to actually go through and do a little bit of work on this. So telling you what the final answer is going to be. Tangent alpha. So let's start with tangent theta. Let's start with sine theta times secant theta. And let's see. So I'm starting here. I'm going to end up with tangent theta. And then they're going through and you look and see which one of these has the correct work, showing all the steps. This is going to be a formal proof here. So we start off with sine theta times secant theta. Well, our major, if there's not a Pythagorean identity, our major technique that we have right now is to write everything in terms of sine and cosine. So let's write secant as 1 over cosine theta. And now thinking of these as fraction multiplication, to multiply fractions, you don't need a common denominator. Just multiply straight across. And we have a sine theta times 1 over 1 times cosine theta, which is tangent theta. It's a pretty short one, just to get you accustomed to these bizarre little multiple choice. Which one of them goes through these correct steps, replacing secant theta with 1 over cosine? Looks like it's A. Oh, look, it's not B, because B wrote sine over cosine. No, not that one. Looking, oh, nope, not C. It should have been sine theta times 1 over cosine. Okay? Sine times secant. No, it's not that one either. A is the one that went through the same steps that I did here. Replace secant theta with 1 over cosine theta, and then multiply straight across. This next one, it's number 10 on my list of identities. Your homework problem should be similar to these. I've just printed out a whole lot of them. Well, it's the same thing. You're going to start with tangent negative x times cosine x and end up with negative sine x. Generally, remember, equality is reflexive. A equals B is the same thing as B equals A. Generally, you start with the messy side and try to simplify to the less messy side. And on this one, we're going to need to use these negative angle identities. We're going to use the fact that cosine is an even function and all the other four, cosine and secant, are even functions, and all the other four are odd. Oh, whenever you could just drop a negative, we call those sort of functions even, like an even exponent. 5 squared is the same thing as negative 5 squared. And these down here are odd functions. Now, let's see what we can do. See, tangent negative x. So I'm starting with this tangent negative x and then times cosine x. Now I want to simplify it down to negative sine x. Well, first this tangent negative x, tangent's odd. You can factor that negative out in front. So it's negative tangent x times cosine x. Now, let's do the same old trick we've been using. Try writing everything in terms of sine and cosine, which means this tangent, I need to write as sine x over cosine x. This negative is that negative, that negative. And is this about to fall out pretty easily? This blue cosine x is that one. And now if we think of that as cosine x over 1, all of that cancels, leaving a negative sine x. So let's look through. Which one did what we did? Well, it's sure not this one. It didn't factor that negative out in there. Then tangent is sine over cosine. They did correctly rewriting the tangent as sine x over cosine x here, but this is wrong. There shouldn't be times a negative. See that negative right there shouldn't be there. Let's look at this one. Tangent negative x. So we wrote as negative tangent x times cosine x. Rewriting tangent x is sine x over cosine x times cosine x. Okay, it is D. Now let's look at another one. Verify this identity. Tangent theta times cosine theta times cosecant theta equals 1. Probably what you're going to do is rewrite each one of these in terms of sine and cosine. Take the tangent theta. It would be sine theta over cosine theta. And what I'm about to write is in blue is that cosine theta. And in red, let's rewrite cosecant theta. That would be 1 over sine theta. A lot of stuff now cancels. The cosine theta, if you think of that as over 1, the cosine thetas cross cancel. Do the sine thetas also cross cancel? Yeah. Okay. So which one is going through what we did here? It's not this one. That cosecant should be 1 over sine. So it's one of these. Is it the first one? Tangent is sine over cosine times cosine times 1 over sine, and then they don't show the crossing out and the canceling. It just says equals 1. There. Sort of moving through here. These are called verifying identities. You're actually going through proving that one side equals the other side. Generally, you start with the more involved side, the messier side. Let's see, what could we do on this one? Sine x plus sine x times cosine, times cotangent squared x. Well, couple of ways we could go about this. When you look at this, what you might think to do, realize we want it to end up equaling just cosecant x. What we could do is factor out a sine x from each term. If we factored out a sine x, what would have to be in the parentheses in order to get that when you distribute? You'd get a 1 and then a plus sine x times cotangent squared x. Distribute the sine x. You'd have sine x plus sine x cotangent squared x. So I factored that correctly. Now that 1 plus cotangent squared x is sure bringing to mind an identity. 1 plus cotangent squared x is cosecant squared x. So we'd have a black sine x, and all this purple stuff, the 1 plus cotangent squared x, I could just write cosecant squared x there. I'm going to put some little equal signs. And now, I think of cosecant squared x as, so this purple cosecant squared x is 1 over sine squared x. So I think we're going to do some more of that cross canceling right now. cancel this black sine x with one of these purple sine x's, we'd have a 1 on top, and just 1 times sine x is sine x. And is 1 over sine x cosecant x? Is that what we wanted to end up with? Yeah. So which one of these goes through like this? Oh, it's not A. You're following what we're doing here? You're looking through and seeing which one's showing the steps. This one factored it right, but the next statement shouldn't have any fractions. It should just be sine x times cosecant squared x. Oh, actually, you know what they've done? Well, this one does it, but that's not the sequence of steps that they're doing. If you look, I wrote everything in terms of sine, but what they're doing is right here, they're writing everything in terms of cosecant. And there's more than one way of doing this stuff. Let me show you. If I wrote sine x as 1 over cosecant x times the purple cosecant squared x, you can cancel this cosecant x with one of those and get cosecant x. So, oh well, I circled it, but all the work is the answer. And so, while this was correct, and this is how I would normally do it, my habit is to generally write in terms of sine and cosine. That's not what whoever programmed this problem to do. They rewrote, once they got to this step here, they rewrote the sine as 1 over cosecant, since you want to end up with a cosecant. And so, okay, which one of these went through doing what I have here? I'm thinking it's going to be B. Sine x times 1 plus cotangent squared x. Now they're putting several steps together. They're replacing the sine x with 1 over cosecant, and they're replacing the 1 plus cotangent squared x with cosecant squared x. But it is B that goes through those steps. Number 13. I guess I can just work this one down here. There's room down there. So let's see. Cosine squared x minus sine squared x equals 2 cosine squared x minus 1. That's one of the double angle identities for cosine 2x. At this point, you don't know what the heck I'm talking about. But once we discuss double angle identities, in a few more lessons, you'll know what I mean by that. So we're starting with the cosine squared x minus sine squared x. We're trying to end up with the 2 cosine squared x minus 1. So I'm going to start with these. Cosine squared x minus sine squared x. Now look at what we're trying to end up with. We want to end up with just with 1s and cosine squares. So this is some of that stuff where I need, this brings to mind something. Whenever I see these squares and sine and cosine, I think sine squared x plus cosine squared x equals 1. Oh, they cut the lights out on me. So we want to have cosine squared x's, so that makes me think we need to get rid of this sine squared x. So sine squared x could be written as 1 minus cosine squared x. So if I replace cosine squared x, excuse me, if I recopy cosine squared x, then I have this minus. In place of this sine squared x, I'm going to put 1 minus cosine squared x. But you've got to be careful. This blue minus here should apply to all of that. So what am I trying to say I need to do? I need to distribute that minus. So we have cosine squared x minus 1, and then plus another cosine squared x. And are we pretty much going to have this statement here now? Cosine squared x plus cosine squared x is 2 cosine squared x minus 1. So which one of those went through these steps? And in order to keep these things short, you're going to notice that they're sort of skipping a few steps here and there, okay? Actually, they're doing they didn't, by skipping a step, they didn't show distribute the minus. Didn't show this statement here, okay? But it is a, okay? Hopefully you're following what we're doing, working with these identities, rewriting. This is just called, what we just did was we verified an identity. We showed this equals that. And we showed the steps. That's what it means to say verify or to prove an identity. You must show the steps. Let's see. Oh, let me lower this. This is number 14. Sine squared t over cosine t equals. When you look through, okay, we're going to start with the sine squared t over cosine t. And so you look at this, it sort of gives you some hints on what you're going to be doing. We need to rewrite this all with just cosines, not any sines. If we want it to end up with secant t minus cosine t, remember secant is 1 over cosine. Well, we want 1 over cosine t minus cosine t. So that brings to mind that first Pythagorean identity. In fact, I'm going to use exactly what I used right here. Sine squared x is 1 minus cosine squared x, except now we're using a t. Sine squared t is 1 minus cosine squared t all over cosine t. Then if there's just one term in the denominator, you can't do this if there's any addition or subtraction, but if there's one term in the denominator, you can separate it. So that would be a 1 over cosine t minus cosine squared t over cosine t. And I think we've about done it at that point, haven't we? The 1 over cosine t is secant t minus cosine squared t over cosine t is just cosine t. So which one went through all of these steps correctly? It's not A. Notice they reversed that. It's not B. There's a plus there. What about C? 1 minus cosine squared t over cosine t. Separate. And then 1 over cosine t is secant. Cosine squared t over cosine t. Cosine t. It is C. Sort of flying through these. I printed out a lot to do here. Number 15, there's probably a few wrong ways of doing this. What do I mean by wrong? Tangent square over tangent, people probably think of that as just tangent x. and this, what I'm doing is wrong right now. Just cancel a tangent, cancel a sine, and that's not listed as, oh well, it is a wrong thing right here. Okay? Before you can start canceling a denominator like that, you can only cancel factors. So this tangent squared x minus sine squared x, you would have to factor that as a difference of squares. Do you remember how to factor something like a squared minus b squared? Oops. It would be a minus b times a plus b. That's how I'm going to factor tangent squared x minus sine squared x. It would be tangent x minus sine x times tangent x plus sine x all over that tangent x plus sine x. That's the key part of the problem. Once you do that, you can cancel all of this and all of that, leaving you just tangent x minus sine x. So which one does that? Well, it's not C, because both of those are minuses. It's either this one or this one. Oh, look here. Should be a plus in the bottom, not a minus. So nope, it's this one. Notice how, I guess the software doesn't show the canceling, maybe because it would look too messy if it did. Now here's one where you just simplify. Notice it doesn't give you the answer. Well, they give you 4 possible answers. It says perform the indicated operation and simplify the result. Well, this one I'll do on a separate sheet of paper. I'm going to recopy. Well, 1 over 1 plus cosine x. Then this minus, I'm about to write, the red minus is that minus. 1 over 1 minus cosine x. Well, in order to subtract fractions, you've got to have a common denominator. So that common denominator is going to be a blue 1 times cosine x times a purple 1 minus cosine x. So on this first fraction, there's already a 1 plus cosine x. So I need to multiply above and below by the 1 minus cosine x. So we just have 1 times all of that 1 minus cosine x. Now do the same thing over here. It has the 1 minus cosine x. It needs a 1 plus cosine x down here. So I'm going to multiply above and below by 1 plus cosine x. This 1 times 1 plus cosine x is just 1 plus cosine x. But be careful. This red minus sign should be distributed. I guess I could have distributed it when I multiplied by the 1, and that'd save me 1 step. So I would have 1 minus cosine x, then a minus 1, and a minus cosine x, all over. Oh gosh, let's go ahead and distribute, or FOIL out this 1 plus cosine x times 1 minus cosine x. Now I'm trying to show the answer choices, but we're going to try to get some answers that look like that. FOILing out this bottom, we'd have a 1, and then what's happening with the outer and inner? 1 times negative cosine x and cosine x times 1. Those are subtracting out. We'd have a negative cosine x plus cosine x. So that's a minus cosine squared x. So up on top, see what's subtracting out? Not the cosine x's. The 1's are subtracting out. On top, a negative cosine x minus cosine x. Negative 1 cosine x plus a negative 1 cosine x is a negative 2 cosine x. All over, you're starting to recognize that 1 minus cosine squared x. 1 minus cosine squared x would be sine squared x. First glance, I'm thinking, well, the answer is D. But no, because we have a minus here, D doesn't have a negative. Well, what can we do here? Well, while no two of these identities are exactly alike, we did do something similar to what I'm about to do in another problem. If we think of that sine squared as just sine x times sine x, we have negative 2, then cosine x over sine x, that's cotangent x. And now I'm going to think of this as times 1 over sine x, cosecant x. I'm thinking the answer is going to be A. Okay. And by the way, when I say I think the answer is going to be, that really means the answer is A. Okay. Brain research suggests that when people hear something that has a little bit of uncertainty, that the brain starts looking for an answer. So when I say I think the answer is going to be A, that uncertainty in the way most people's brains work, they'll start looking and trying to see, is it that one? Yes or no? So there's some logic behind the way I word things. Okay? Number 17. This is going to simplify as either a constant, which is just a plain number, a single circular function, so a single trig function, or a power of a trig function. Okay, so what can we do to simplify all of this stuff? It's going to look a little messy at first. This black fraction bar is that one. Cosecant I can think of as 1 over, oops, that's a beta. So cosecant beta is 1 over sine beta. Tangent beta is sine beta over cosine beta. So I rewrote cosecant in blue, rewrote tangent in red. Secant beta, 1 over cosine beta. Now how's this stuff going to simplify? Well, the sine betas cross cancel, so above the black line I have a 1 over cosine beta, and on the bottom I have a 1 over cosine beta. To simplify this, you can either say a fraction over itself, anything over itself is 1. Or if you want to show more steps, you could say, okay, I'll multiply above and below by cosine beta to get 1 over 1, which is 1, which is going to be that one. Sometimes students say, well, what about this one? No. It should simplify as either a constant, one trig function. Look at that. There's 2 trig functions there. True, you could cancel and it'd simplify down to 1, but that's not the answer there. Okay. Okay, well, I'm not going to do this one. This is one where you should do the X, Y, R. I don't know how it got wound up right there, but you think of in quadrant 2, Y's are positive, X's are negative, Y over 8. Do X squared plus Y squared is R squared. But I want to keep working with identity. Ooh, sorry about that. This one here, where you're given one trig function and told find the others. I'd do the X, Y, R. I wouldn't use identities. I'd use the definition on that one. And we've done some of those. In fact, see, we did some of those right here in part 1 of this lesson, this lecture. Let's see, on number 19, oh gosh, tangent x minus secant, tangent squared x minus secant squared x. Well, if we look at answer choices, somehow I'm thinking in terms of, okay, tangent squared x minus secant squared x. That brings to mind, these are just my thoughts. 1 plus tangent squared x is secant squared x. It's one of those Pythagorean identities. So move the stuff around. So we'd have tangent squared x minus secant squared x equals what? It would be negative 1. So all of that simplifies to negative 1. So it's up to you to figure out which one of these equals negative 1. Okay, it wouldn't be D. That's just a single trig function. What about sine squared x over cosine squared x? Does that equal negative 1? Well, no, that equals tangent squared x. So you have to go through and figure out which one of these equals negative 1. Oh, how am I going to move this around? Okay, I want these Pythagorean identities shown. Well, right, this one here, this thing here, cotangent squared x plus cosecant squared x, and this one, bring to mind this. See, this is how, sometimes students say, well, how would you know to simplify it to this if you didn't have the multiple choice? I would just rewrite it as negative 1. Yeah, this is a multiple choice problem. You sort of got to look at these answer choices. So basically, which one of these simplifies to negative 1? If we take this 1, these are my thoughts. If we take 1 plus cotangent squared x equals cosecant squared x, and move it around the way we did here. Move the 1 over there, the cosecant squared over there. We'd have cotangent squared x minus cosecant squared x is negative 1. Ah, that one. Cotangent squared x minus cosecant squared x. That would give you negative 1. So once you know this simplifies to negative 1, you're sort of looking at the choices and figuring out which one of these simplifies to negative 1 also. The way I did that was take this third Pythagorean identity and move it around the what to get a negative 1 by itself, the way we moved it around up here. Let's see. Number 20. Simplify this expression. Well, what can we do? You're either going to have to FOIL it first or write everything in terms of sine and cosine. I think I'm going to FOIL it out because isn't this in the form a plus b times a minus b? If you start FOILing this out, you're going to have cosecant squared x. And what's happening to the outer and inner? I'll do those in red. We'd have or pink. Negative cosecant x cotangent plus cosecant x cotangent. That outer and inner subtract out, don't they? And then a minus cotangent squared x. It sounds like I've got to do a little bit of thinking here. Which identity is this bringing to mind? Well, that one I just used up here, the 1 plus cotangent squared x equals cosecant squared x. But I'm going to have to move it around differently. This time, if I want to get what I have right there, I'll have to move that cotangent squared x over to the right. So we would have cosecant squared x minus cotangent squared x equaling 1. So this is equal to 1. Cosecant squared x minus cotangent squared x is 1. What about this one? 21. What can we do on this one? This is going to be a long assignment. You have a lot of these identities to simplify. Well, right off I look and I don't see something I can cancel, but secant x sine x. If in doubt, write it in terms of sine and cosine. I'll rewrite cosecant is 1 over sine x minus cosine x. And then we have all over. Oh, I guess I didn't rewrite that secant as 1 over cosine. But I'm curious what's going to happen. I guess I should have. I didn't write this one as 1 over, well, I'll just do that. You know what? Let me just start all over, rewriting everything in terms of sine and cosine. I rewrote the cosecant as 1 over sine. I didn't write the secant 1 over cosine x times sine x, parentheses, 1 over sine x minus cosine x, all over secant x is just 1 over cosine x minus sine x. I'm betting that, or I'm thinking once we distribute all of this stuff is going to cancel pretty nicely. I'm distributing 1 over cosine x times sine x. So right here, the sine x's would cross cancel, leaving us just a 1 over cosine x minus all of this times cosine x. The cosine x's would cross cancel, leaving just a sine x. Oh, wow. Y'all see it? How is this going to simplify? You have one big fraction with the same thing on the top and on the bottom. You don't need to do anything else. Something over itself equals what? 1. So 19 and 20, both of those answers were 1. Rushing, we're out of time. Oh, wow. Number 22. Number 22. gosh. If I want to simplify this fraction, I'm going to have to cancel something. In order to do that, I need to factor that top. So if I factor that top, I'd say cotangent x times cotangent x. And then I need two numbers that multiply together to give 8. Either 1 times 8 or 2 times 4. 1 times 8 is what I'm going to use because I want a -7 cotangent x as the middle term. So the 1 and 8, in order to get a -8 when I multiply, one of them needs to be positive, one negative. I'm going to put it like this. That would give me the -7, but also, the reason I'm thinking there should be a +1 there, so it'll cancel with that. Now I forgot, we still have this minus cotangent x right here. So minus cotangent x. So let me write out what's remaining. We have this purple cotangent x minus 8. I'll write it without parentheses. Then a minus cotangent x. What's that going to simplify down to? Just a -8. And we end up with one of these establish the identities. Well, let's see, we're out of time, so I'm going to do this really fast. We want to start with tangents and end up with cotangents. So the key to doing that, if you're going to start with tangents and end with cotangent, is to rewrite that tangent as 1 over cotangent. So I'm rewriting 1 plus, I'm rewriting that tangent v as 1 over cotangent v. This red fraction bar is that one. 1 minus, rewrite the tangent v as 1 over cotangent v. So let's see. Oh, there's only 3 of these. You know what? At this point, this has got to be the correct statement. There's no way you're going to rewrite tangents with cotangents without making that statement. I know we're out of time, so if you have to go, go. But it can't be this one or this one. Tangent is not 1 over secant. Okay. And what the heck are they doing on that one? So on this one, what you would do next to get rid of these compound fractions, multiply above and below by cotangent v. Remember years ago the students saying you're just making these things work out. And, well, yeah. 1 times cotangent v is cotangent v. 1 over cotangent v times cotangent v, those cancel, so that's getting you the +1. And then cotangent v minus 1 over cotangent v times cotangent v. Answer is definitely A on that one. And then we're back here. Oh wow, so we did just about every one of the ones I printed out except this number 18. Oh, I'll just feel better if I do it. If you have to go, go. So we have x squared plus 5 squared equals r squared. So I'd subtract the 25. So we'd have x squared equals, what's that going to be? At first I thought 49. It's going to work out nice and neat. Well, now it would be 39, isn't it? So x is going to be the negative square root of 39. And then, okay, cosecant is the reciprocal of sine. Cosine is x over r. Secant is the reciprocal, r over x. You'd have to rationalize. Tangent y over x, rationalize. cotangent x over y doesn't need rationalizing. And so we're out of time. So work on these identities. It takes a lot of practice. This isn't something you can do just sit down and get them all done in 15 minutes. And you've got to work on them some. Okay? And we're going to have another assignment after this one that's just more of the same, more of these identities to either verify or simplify. Okay? Okay, thank you for listening. Bye-bye.